So another method that I can use is called Gaussian elimination. And so in order to do this, what I need to do is write my equations in a particularly neat organized form. So I'm going to do it like this. So basically what I'm after is like a column per variable. So from my first equation, I have no v3, so I'm going to kind of leave a bit of a gap there. And I also want to have all my coefficients on the right-hand side. So my second equation will look like this. So minus 4v1 plus 5 v2 plus 14 v3 is equal to 120. And then my last equation, because I have these 7.5, like this annoying decimal point, I'm just going to multiply this equation by 2 just to give me integers. So I'm going to have minus 2v1 minus 15 v2 plus 15 v3 is equal to 0. And so now that I have this system of equations written in this form, what I can do is turn this into a matrix. So in order to write the matrix system for this, what I do is just read off the coefficients. So I have here in the column for v1, I have a 4, I have a minus 4, and I have a minus 2. And you see these are all the coefficients that are associated with the v1 variables in my system of equations. Next, I can write down the variables that I have, or the coefficients for my v2. So that's a minus 3, that's a plus 5, or I'll just write 5, and a minus 15. Then I have a 0, 14, and 15. I then draw a little line and I put the numbers on the right-hand side. So that's 36, 120, and 0. So this thing is called the augmented matrix form. So it's a systematic way, like a shorthand way of expressing all the information in a simultaneous system of equations. So now I will do some updates on this in order to try and solve this system. And in particular, what I would like to do is get this into what's called an upper triangular form. So upper triangular means like this part, which you can imagine kind of looks like a triangle, that I'll have numbers on the upper triangular part, and I'll have zeros elsewhere. So the lower triangular portion is going to be 0. So in order to do that, I can have these little update steps that I apply to my matrix. So in particular, for the first row, I'm actually just going to leave it as is. So I will just copy those numbers down. But then for the second row, I'm going to do this update, which is R2 plus R1. So I can kind of add together combinations of these rows. So here if I, like the reason why I'm doing this, the reason why I'm saying R2 plus R1 is I'm looking here at these numbers in the first column and I see that I've got a plus 4 and a minus 4. So if I add them, I'll get 0. And zeros is what I'm after. So I'm going to add these rows together. So adding in the first column, I will end up with 0. In the next column, I'll end up with 2, 14, and 156. So I'm just adding together each of the corresponding numbers in those rows. Then for the third row, again, I would like a 0. And the way to achieve that is that if I add 1/2 of row 1, so I'm looking at the numbers over here, I'm looking at the minus 2 and I'm looking at the 4. If I add half of the 4, it will cancel with the minus 2. So let's go ahead and do that. I will get a 0 in the first position. For the next one, just to be completely clear about this, I'll kind of write down the numbers. So I've got a minus 15, and I'm going to add to that 1/2 of, well, the number here was actually a minus 3. So I'll just go and calculate that. So it's actually a minus 15 minus 3 over 2. So that's a minus 16.5. So I will write minus 16.5 in here. Then for the next one, I had a plus 15. And I'm adding a half of row 1. Well, it's a half of 0. So that's just 15. So I'll write a 15 here. And then for the last one, I had a 0 and I was adding 1/2 of row 1. So 1/2 of row 1 is a half of 36. 1/2 of 36 is 18. So I'll just write an 18 there. So in that way, I have done like an update step, which is kind of getting me closer to solving this system. Another way that you could think of it is that I've kind of eliminated the V1s. There's no V1s left in these two system of equations. So it's kind of analogous to that substitution procedure from the solving it by elimination. So let's keep going. The next thing that I would like to do is get a 0 in this next position over here that I've highlighted. So how can I get a 0 there? Well, first I'll just copy the first two rows, because I'm not going to change those just yet. So let's copy them down, 14 and 156. And then I want to do some kind of update. So it's going to be R3 plus, something times R2. And I need to use R2 because I need there to be a 0 in this first column over here. So it has to be something times R2. So if it's not obvious to you what is the coefficient, then you can actually calculate that. So the answer that I want in this cell, the answer that I want here is going to be 0. And it's going to be obtained by starting with minus 16.5 and then adding some multiple of the coefficient in row 2. Well, that's 2, a times 2. So this tells me that I will have my coefficient of a is going to be minus, so 16.5 divided 2 is 8.25. Oh, excuse me, the a is, this is positive. What am I doing? Bring the 16 to the other side of the equation and divide through by 2. So I'll get 8.25. So the update step that I actually want to do here is 8.25 times row 2. So let's go ahead and actually do that. I'll write down what the values will be. I'll get 0 in the first cell. In the next cell, I started with 16.5, and I'm going to add 8.25 times the coefficient there. So that's 8.25 times 2, and that's going to be 0. For the next one, I initially had a 15 in that cell. I'm going to add 8.25 times 14 to that. So 15 plus 8.25 times 14 is 130.5. So I will write 130.5 in there. And then in the augmented column, I will have 18 plus 8.25 times 156. So that is 18, just bear with me while I calculate, is 1,305. So 1,305. So this now gives me, gets me much closer to having solved this system. So let's actually sort out this final row. Basically, this final row is sorted, and I can kind of read off the values from that. So I'll just copy the other ones down, and I'll show you how I would use this information. So that I had 0, 2, 14, 156, and I'm going to do a little update here. And in particular, what I'm going to do is row 3, and I'm going to divide it by 130.5. So I can just multiply or divide by constant values. So that's going to give me a 1 in this position, and it's going to give me a 10 in this position. So that 10 came about because I did 1305 divided by 130.5, which is equal to 10. So that lets me let's just kind of simplify the numbers a little bit. And this is really nice because if I look at this bottom row, then I can kind of read off what's the equation that would relate with that. So, I have a 0v1, forget about that. I have a 0v2, we'll cancel that one. I have a 1v3, well, that's good, is equal to 10. So I've actually already solved for v3. There's no further work that's needed. It's just the value 10 that appears in the right-hand side of this augmented matrix. But if I want to solve for the other numbers, then I have, or the other variables, then I have just a little bit more work that I need to do. So now that I have this convenient value 1 here, then I can actually use that to eliminate the 14 that's in the row above it. So I can write another little update step that will kind of get me to the answer for my second variable, for the second row of this matrix. So let's go ahead and do that. So that's 4 minus 3, 0, just keeping the first one the same. Then the second one that I'm going to do, this update step here, so I'm going to start with R2, and then I'm going to subtract 14 times R3. And so why am I subtracting 14 times R3? Because I'm looking at these numbers here and I'm thinking I need to get a 0 in the highlighted cell. And so I can get a 0 in the highlighted cell by subtracting 14 times R3. So let's go ahead and do that. The first two columns will not change because there's zeros down the bottom. I'll end up with a 0 here, and then in the augmented position I have 156, and I'm subtracting 14 times the value that's in row 3, that's 10, so 14 times 10. So this is 156 minus 140 is just 16. So I have a 16 here, and then the bottom row I'm just going to leave it kind of as is, because that one's already solved. I already have the lovely 1 on the diagonal and just the constant in the augmented position. So I'm nearly there, and what I will do at this point is basically just rescale. I like to have 1s on the diagonal, because if I have 1s on the diagonal, then I can just read off the answers directly from the right hand side. So what I'm going to do here is just take R2 and divide it by 2. Second row, divide by 2, and that will just give me a 1 in this position and will give me an 8 over here, and then bottom row stays the same, looks like that. So I'm nearly there. The only thing that's standing in my way is that I have this minus 3 here in the second column. So I need to again do another little update step in order to get rid of that. So let's just write down what we can possibly do. So I would like to get a 0 here. I could get a 0 by adding 3 times the row below. So row 1 plus 3 times row 2, because I'm just looking at these numbers and I see a 3 and a 1 and I need to cancel them to get to 0. So that's the update that will get me there. So let's go ahead and calculate that. So in the first column I will have 4 plus 3 times 0, well that's just 4, so I'll have a 4 there. In the next column I'll have a minus 3 plus 3 times 1, well that's just 0, so that's good. This next one, 0, 0, is going to give me 0. In the augmented column I'm going to have 36 plus 3 times 8, so 36 plus 3 times 8 is 60, so I'll write here 60. Then the other rows I will just keep as they were, 0, 0, 1, and 10. And so then in my the final thing that I need to do is kind of scale this first row. I just want to get 1s on the diagonal. So it's always 1s on the diagonal is kind of the final goal of doing this complete reduction procedure. So in order to achieve that, the scaling that I need is R1 divided by 4. It's 4 because there's a number 4 basically over here on that diagonal column. So R1 divided by 4. So let's calculate that. So that will give me 1, divide 4, it gives me 0, and then I will have 60 divide 4, which is 15. So now I'm done. This is it. I have actually solved this system of equations, and I can just read my answers from this column here on the right hand side. So in particular, let's go and write down what this system of equations actually means. So from the first row, I have V1 equals 15. From the second row, I have V2 equals 8. And from the third row, I have V3 equals 10. These are all units of volts. So that's the system of equations solved. That's my solution, and I've solved all three of them at once. And so there I get my answers.